Assalamualaikum and good day everyone. So for chapter 6 is polynomial. We will have three subtopic, which is the first one is 6.1 general information about polynomial, and the second one 6.2 remainder, factor and zeros of polynomial, remainder theorem and factor theorem, also zeros of polynomial, and the last one is partial fractions. Okay, so for today we are going to focus on the first subtopic, which is polynomial. So, the learning outcome for this lesson, at the end of the lesson, students should be able to perform addition, subtraction, and multiplication of polynomial, perform division of polynomial. So, what is polynomial? A polynomial, p of x, so this p is only a representation of polynomial. Okay, so it can be anything. It's not only p, but for this here we use p to represent a polynomial of a degree n is defined as p of x equal to a n x power of n plus a n minus 1 x power of n minus 1 plus dot 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 plus a1 x plus a naught, where a n must not equal to 0. Means that we will have x to power of n, where n is the degree of the polynomial. So there should be a coefficient for the x to power of n, because an here must not equal to 0. Then this x to power of n will be exist. Okay, and n is any positive integer, and a naught, a1, a2, and so on up to an are coefficient of the polynomial, and an is the leading coefficient. Why? Because it's the coefficient of the x with the degree of the polynomial. Okay, so because this is looks like confusing, really confusing, right? Because it's all the variables. Just remember a quadratic. Okay, so let's say the example of quadratic. Quadratic is ax squared plus bx plus c, right? So the highest power of x there is 2. So the 2 is the degree of the polynomial. And the a, it can be any constant lah. So this a is actually the coefficient, the leading coefficient, because it's coefficient of the x power of 2, the highest power or the highest degree of the polynomial. Okay, so this polynomial can be anything. This n can be any positive integer. It can be 100. Okay, it's not only up to quadratic or cubic. We have many form of polynomial. Okay, many, poly, name. Okay, and a naught is the constant term. Why constant? Because we actually has x to the power of 0. So x to the power of 0 is equal to 1. That's why we only put the constant there. The degree of the polynomial is determined by the highest power of x. So the highest power of x here is n. So n is the degree of the polynomial. Basic function. So we have learned actually in chapter 5. The first one is constant function, fx equal to a constant, and linear function ax plus b, where x to the power of 1 is the highest power of the function, and fx equal to ax squared plus bx plus c, where a must not equal to 0, which is a quadratic function, as I said earlier. And then we have a cubic function, ax cubed plus bx squared plus cx plus d. And all of these functions are special cases of general class of function called polynomial function. So this is our special cases of polynomial. The one that we always use in calculus. Okay. Example of non-polynomial expression. So we have x to the power of 1 over 3. Okay, that 1 over 3 is not an element of positive integer. Okay, that's why we cannot call it as a polynomial. And then we have 5 over x plus 3 to the power of x minus 1. This is negative. This one also x to the power of negative 1. Okay, so it's not a polynomial. And this one, because we have a power of 1 over 2, we cannot expand it or anything. So this is not a polynomial. And we have square root of x. Square root of 7 is okay. Why? Because it's just a coefficient. But this square root of x here, okay, it's not an integer. The power is not an integer. Contain non-positive integer power of x. Example of polynomial function. So we have property of x, p of x, polynomial of x equal to -7. This is a degree of 0 with leading coefficient equal to -7 and constant term is -7 and the name of the polynomial is a constant. And then we have px equal to 5x minus 6, which is the degree, the highest degree here is, the highest power is 1. So the degree of polynomial equal to 1. The leading coefficient is the coefficient of the highest power, which is 5, and constant term here is -6. So this is a linear. And then px equal to 7x squared plus x, where the degree of the polynomial is the highest power, which is equal to 2 here. And then what is the leading coefficient? The coefficient of x squared is equal to 7, and the constant here is equal to, we don't have any constant, so it's 0. So this is a quadratic. And we have px equal to 2x cubed minus 7x squared plus x plus 3. So what is the degree? So we have the highest power of 3, and then the leading coefficient, the coefficient of x cubed is equal to 2. And the constant term here is 3. So we call it as cubic function. And property of x to the power of 4 plus 5x plus 5 is having a degree of polynomial equal to 4, because the highest power here is 4. And then the coefficient of the highest power is equal to 1. And the constant term here equal to 5. What is this function? So this is a quartic. Okay, so you can differentiate between these 5 types of polynomial: constant, linear, quadratic, cubic, and quartic. So the algebraic operation of polynomial, we have plus, minus, multiply, and division. So let's do some example. So if px equal to 4x squared plus 3x minus 5 and qx equal to 3x squared minus 5x plus 2. So what we need to do is to just do the operation between the same degree of x. Okay, so for example, if we have px plus qx, so we have a function, we have a polynomial of px equal to 4x squared plus 3x minus 5 plus with a qx, which is 3x squared minus 5x plus 2. So we do operation between the same degree. So for x squared here and x squared here, so we have 4 plus 3, which is equal to 7x squared. The same for x, which is equal to 3 plus 3 minus 5 here, so it will be 3 plus -5, so 3 minus 5 equal to -2. And the last one is the constant, -5 plus 2. So -5 plus 2 equal to -3. So we have 7x squared minus 2x minus 3. Really simple, right? For px minus qx, so what is px? So we subtract each of the coefficient of the polynomial. So for x squared, we have 4 minus with 3, so we have x squared. 3x minus -5x will be 3x plus 5x, which is equal to 8x. And -5 minus plus 2, it will be -5 minus 2 equal to -7. So we have x squared plus 8x minus 7. And for px multiply with qx, so we have multiplication between two polynomials. What we need to do, we just have to expand as usual. So because we have 3 terms, it should be 1, 2, 3, 1, 2, 3, 1, 2, 3. It should be 9 terms here. So you have to be careful. Okay, so do it step by step here. So 4x squared multiplied by 3x squared, we have 12x to the power of 4. And then 4x squared multiplied -5x, we have -20x cubed. Using the rule of indices. Okay, so we have x squared multiplied by x squared, it will be x2 plus 2, so we get x power 4. For x multiplied by x squared multiplied by x, we have x squared plus 1, so it will be x power 3. So 4 multiplied by -5 is -20. And the last one, 4 multiplied by 2 is 8. And x squared multiplied by nothing here, x power of 0. So it will be x squared. So we continue with the next term. 3x multiplied by 3x squared will be 9x power of 3. And then 3x multiplied by negative 5x will be negative 15x squared. And plus 3x multiplied by 2 will be plus 6x. And the last one, negative 5 multiplied with everything. We have negative 5 multiplied by 3x squared will be negative 15. And negative 5 multiplied by negative 5x will be positive 25x. And negative 5 multiplied by positive 2 is equal to negative 10. So simplify everything. Group the same degree respectively. So we have x cubed here and x cubed here. So for x power of 4, we only have 1. So 12x power of 4. And then negative 20x cubed plus 9x cubed will be negative 11x cubed. And for x squared, we have 1, 2, and 3. So 8 minus 15 is minus 7. Minus 15 again, minus 22. X squared. And then for x, we have 1, 2. So 6 plus 25 is 31. And the last one is a constant, negative 10. So this is the answer. The final answer is equal to 12x power of 4 minus 11x power of 3 minus 22x squared plus 31x minus 10. Okay, now we continue with division. Generally, for a polynomial px with degree n can be divided with a polynomial dx divisor, where dx must not equal to 0 with degree r, and r should be less than or equal to n. It cannot be more than n. So the division of px with dx will give qx, which is the quotient with degree of n minus r. So the quotient will be the polynomial with degree of n minus r, the polynomial with minus the divisor, and rx as the remainder with degree less than r minus 1 or 0. So we will have this form, px over dx, the polynomial divided with the divisor will equal to qx, the quotient, plus with the remainder divided by divisor. Okay, for example, in your high school, so we have 12 divided by, no, cannot, 12 is a really nice number. So we have 14 divided by 3. So this 14 is your, let's say it's a polynomial. Here is just number, right? We assume it as polynomial, just as an example. So what you need to do, we usually use 14 divided by 3. So what is 3 multiplied with to have value less than 14? So we have 3 multiplied by 1 is 3. 3 multiplied by 2 is 6. 3 multiplied by 3 is 9. 3 multiplied by 4 is 12. 3 multiplied by 5 is 15. Okay, 15 is more than 14. So we take 4. Because 4 multiplied by 3 is 12, which is less than 14. So what do we have? 14 minus with 12 is 2. This can be written as 4 2 over 3, right? So this is actually the quotient plus with the remainder divided by the divisor. Okay, so a quotient plus with the remainder divided by the divisor. The divisor here is 3, right? The polynomial is 14. Okay, so this is in the form of the number that you have learned in high school. So now we have to relate it with the polynomial. Let's do the division together. Okay, another form to write down this division is px. So we have to eliminate the dx here. So we multiply everything with dx. So what's left? On the left side, we don't have any dx, but the quotient need to be multiplied by dx. So we have quotient multiplied by divisor, plus with the remainder also will cancel out the divisor. So we have the remainder on the right side. So we have two forms of division of polynomial. Okay, the first one is px divided with dx equal to qx plus rx divided by dx. And the second one is px equal to qx multiplied by dx equal to plus with rx. Okay, When dividing polynomial, the quotient and remainder can be found by using long division. This is what I said earlier. 20 divided by 3, long division. So the smaller value multiple of 3 is 18, which is 6 multiplied by 18. So 20 minus 18 is equal to 2. So we can write down this as 2 is the remainder, 6 will be the quotient, and divisor is 3. So it will be quotient 6 plus with 2 over 3. So 6 2 over 3 is equivalent to 20 over 3. So this is the same form as I said earlier. Px over dx is equal to qx plus rx divided by dx. So if we multiply everything here with the divisor, multiply by 3, what do we have? We have 20 is equal to 6 multiplied by 3 plus 2, right? Because 6 is the quotient, multiplied by divisor plus with the remainder. 6 multiplied by 3 is 18 plus 2. Okay? Okay, so for example 2, divide x squared minus 4x plus 3 by x plus 1 in the form of px equal to dx qx plus rx. So now, this x squared minus 4x plus 3 here is our polynomial. We want to divide by x plus 1, so this is our divisor. Okay, so we need to find by using long division lah. So x squared minus 4x plus 3 divided by x plus 1. So by using long division, we have this. So how to do the division between polynomial? So what we do during the number division, long division for numbers, the same thing we do here. But here we need to use x to multiply, right? So let's say for x squared here, we have divisor of x. So how do this x getting into x squared? So this x should be multiplied with another x, right? So x multiplied by x, so the quotient here will be x. So after that, what we need to do? We know already the quotient. We need to find what is the exact value. The same as 20 divided by 3. So we know we have to multiply by 6 the 3. But 6 multiplied by 3 is actually 18, right? So we have to subtract here. So the same thing here, we have to multiply with the divisor again. So x multiplied by x is x squared. And then x multiplied positive 1 is x. And then what we need to do, we have to subtract. So x squared minus 4x subtract x squared plus x. So x squared minus x squared is equal to 0. But negative 4x minus positive x is equal to negative 5x. It's negative 4x minus positive x. So this will be negative. So negative will be negative lah. Negative 4 minus 1. So will be negative 5x. And then what we need to do, we bring down the plus 3 here. Okay, so let's say for example, we do the bigger number. So we have 200 divided by 3. Right? So we know it should be multiplied by 6. So it's equal to 18. So we have the 2. So we still have the 0 here. So we have to bring it down. The same thing here, we have to bring it down the positive 3 here. And then we can still divide this negative 5x with x because the power is the same. So the degree here is still the same. We have x to power of 1 here. Here also the divisor is still x to power of 1, which is the divisor r should be less than or equal to n. So here the power is the same, so we can still divide. Okay, now for x here to be negative 5x, what we need to do? Yes, x, we have the same x, but the coefficient here is 1. So to get negative 5, we have to multiply with negative 5. So negative 5 multiplied by x is negative 5x. Negative 5 multiplied by positive 1 is negative 5. So subtract these two expressions. So we have negative 5x plus 3 minus negative 5x minus 5. So negative 5x minus negative 5x is, here will be plus, right? Okay, so it will be 0 lah. Confirm it will be 0. And then for this one, 3 minus negative 5. So it will be 3 plus 5, which is equal to 8. So what do we have here? Okay, so we see what is our px. So the px is the polynomial that we want to divide. Okay, so we have x squared minus 4x plus 3 is our px, and then x minus 5 is our qx, the quotient, and 8 is the remainder, rx, and x plus 1 is the divisor. So now we just have to put all of these following the form of px equal to dx qx plus rx, which is px x squared minus 4x plus 3 is equal to dx x plus 1 multiplied by qx x minus 5 plus with the remainder, which is equal to 8. So this is the answer. Okay. Okay, so let's do example 3. So determine 2x cubed minus 3x squared minus 4x plus 1 divided by x minus 4 by long division, and write in the form of px equal to dx qx plus rx. So what we have here, we have px equal to 2x cubed minus 3x squared minus 4x plus 1 divided by x minus 4. So by using long division, we have to find out for 2x cubed. So 2x cubed here, we have only x. So what we need to do, we don't have enough x by power of 2, right? Okay, so or another method you want to find the quotient is what we have for px, we have 2x cubed. So we need to divide by x. So by using the rule of indices, what we have here is 2x cubed minus 1, 3 minus 1, right? So 2x squared. So this is our quotient. So we found out already the quotient here is 2x squared. So put 2x squared there. So we have 2x squared. So don't forget to multiply back again so that we can find out what is the remainder. So we have 2x squared multiplied by x is 2x cubed. Then 2x squared multiplied by negative 4 is negative 8. 8x squared. So subtract this. So we have 2x squared, 2x cubed minus 2x cubed equal to 0. But negative 3x squared minus negative 8x squared will be 5x squared. And then bring down the negative 4x. So for x, to get 5x squared, so 5x squared divided by x, so we have 5x. So the quotient here is plus 5x. Okay, and then find the result. So 5x multiplied by x is 5x squared. 5x multiplied by negative 4 is negative 20x. So subtract, we get 0. And then negative 4x minus negative 20x is equal to 16x. And bring down the plus 1. So plus 1, 16x divided by x. So we have 16 as the quotient. So positive 16 multiplied by x is 16x. And then 16 multiplied by negative 4 is negative 64. So subtract these results. Well, we have 0, and then 1 minus negative 64 is 65. So the answer here is, so we have px, we have qx is 2x squared plus 5x plus 16, rx equal to 65, and x minus 4 is the dx. So px, it should be px, yeah? Sorry for the confusion here. So the px, which is equal to, this is our px, 2x cubed minus 3x squared minus 4x plus 1 is equal to the dx, which is 65. Sorry, dx is x minus 4 multiplied by the quotient is 2x plus 5x plus 16, and then plus with the remainder, which is 65. Okay, so this is for example 3. Example 4. Divide 5 plus 4x cubed minus 3x by 2x minus 3 and write in the form. So this is basically the same. But the function here, px here, is in the form of not unusual form. Why? Because we have constant in front of it. So what we need to do, the first thing is to rearrange back following the degree. The highest degree should be the first term here. So we have the highest here is the power of 3, which is 4x cubed. So it will be the first term. And then for x squared, we don't have x squared, but we represent it as 0x squared to bring the space for the x squared. And then the next one is x. So we have minus 3x, and then the last one is the 5. So it will be 5 plus 5 with the constant. So divide. So we also need to rearrange for the divisor. But here you follow the degree already. X and then a constant. Okay, now use do the long division. So to get 4x cubed, so we have 2x multiplied by 4x squared. And 2x squared, sorry. So multiply the 2x squared with 2x and minus 3. So we have 4x cubed minus 6x squared. And then subtract the value here. We have the remainder of 4x cubed minus 4x cubed is 0. And 0 minus negative 6x squared is 6x squared. And bring down the negative 3x. So to get 6x squared from 2x, what we need to do? Yes, we have to multiply by 3x. So plus 3x. So multiply the 3x with the 2 divisor here. So we have 6x squared, and then plus 3x multiplied by negative x is negative 9x. Okay, so find the remainder. So we have 0, and then negative 3x minus negative 9x is 6x. And then bring down the plus 5 here. So we have to get 6x from 2x. What we need to do? We need to multiply by 3. So plus 3. So plus 3 multiplied by 2x minus 3 is 6x minus 9. Okay. So what we have for the remainder? So 6x minus 6x 0, and 5 minus negative 9 is 5 plus 9, which is equal to 14. Okay. So the answer will be the px equal to dx, which is 2x minus 3, multiply qx, which is 2x squared plus 3x plus 3, and then plus the remainder, which is equal to 14. So this is qx, this is rx, this is dx. Okay, so example 5. Determine x cubed plus 1 divided by x minus 1, x plus 2, and write in the form. Okay, so now we have 2 factors on the denominator. So to use it as the divisor, what we need to do, first thing is to expand it. So actually x squared plus x plus 2, x minus 1 is x squared plus x minus x. So we need to divide x cubed plus 1 with x squared plus x minus 2. Okay? So do the long division for this lah. So what is the long division? We have x squared plus 3. But because we don't have x cubed plus 3, so we don't have the x squared, we don't have the x, means that the coefficient is equal to 0. So it will be x cubed plus 0x squared plus 0x plus 1 divided with x squared plus x minus 2. So do the long division. So from x squared to get x cubed, we will need to multiply by x. So x multiplied by x squared is x cubed. X multiplied by x is x squared. X multiplied by negative 2 is negative 2x. So subtract x cubed minus x cubed is 0. 0x squared minus x squared is negative x squared. Right? And then 0 minus negative 2x is positive 2x. And then bring down the plus 1 here and continue to get x squared, negative x squared. This x squared need to be multiplied by. Okay, remember, even though it's an x squared, but we have different sign. This is positive, this is negative. Means that this x squared here need to be multiplied by negative 1 to get negative x squared. So the quotient here is negative 1. So negative 1 multiplied by x squared is negative x squared. Negative 1 multiplied by x will be negative x. Negative 1 multiplied by negative 2 will be positive 2. So subtract the value here. We get what as the remainder? So negative x squared minus negative x squared. Done already. Finish. And 2x minus negative x is 3x. 1 minus positive 2 is 1 minus 2 is negative 1. So this 3x is the remainder because the degree here is less than the divisor. Okay. Okay, so what is our px, what is our qx, and so on. Okay, if we use this form x cubed plus 1 divided by x minus 1 x plus 2, so we will have, so we shouldn't put this divisor because it's in the form of px equal to dx plus q. Sorry, let me write down this back. What the question asks you is in the form of px equal to dx multiplied by qx plus rx. So px is equal to x cubed plus 1. So please don't do like this one. This is wrong. Equal to dx, which is x squared plus x minus 2, multiplied by qx. This is our qx, which is x minus 1, and plus with remainder. This is our remainder, which is equal to plus with 3x minus 1. Okay? Okay, so last example. Find the quotient and remainder for the division of x cubed minus 27 divided by x minus 3. Okay, now you just do the long division. So by using long division, we have x squared plus 0x squared plus 0x minus 27 divided by x minus 3. So x to get x cubed, we multiply by x squared. So we have x cubed minus 3x squared. So subtract the value here. X cubed minus x cubed is 0. 0x squared minus negative 3x squared is 3x squared. Bring down the 0x. So to get 3x squared, we have to multiply x with 3x. So positive 3x. So 3x multiplied by x is 3x squared. 3x multiplied by negative 3 is negative 9x. Okay, so find the remainder from here. So 3x minus 3x squared is 0. 0x minus negative 9x is 9x. So we have 9x minus 27. Bring down the negative 27. So to get 9x minus 27, to get 9x, sorry, ignore the negative minus 27. To get 9x, we have to multiply x with 9. So plus 9. So plus 9 here, 9 multiplied by x is 9x. 9 multiplied by negative 3 is negative 27. So actually we don't have any remainder. So 9x minus 9x is 0. Negative 27 minus negative 27 is 0. So the remainder here is 0. So what is the quotient? They didn't ask to form the px in the divisor quotient plus the remainder, but they ask you what is the quotient. So what is the quotient? The quotient is here, x squared plus 3x plus 9, and the remainder, we don't have remainder, means that the remainder is equal to 0. Rx is equal to 0. So that's all for this lecture. So it's really easy. This is really simple for the polynomial, the basic knowledge about the polynomial. We just do the operation between the polynomial, which is the addition, subtraction, multiplication, and division. Okay, so that's all for today. Thank you.